One of the things that SingleStore is known for is that with one single database, you can build AI applications, especially enterprise RAG application, with a single short query. And what that effectively means is you can go across multiple data types, whether it's JSON, whether it's a geospatial, key value, and so on. And you can do both a vector search as well as exact keyword search. But what's more important is that you can also create knowledge graphs using just straight up lookup tables between entities and relationships. So what I wanted to do was just to demonstrate that very quickly into a RAG based application that has higher accuracy because it does all of this in one single shot. So let's take a look at what that application looks like. As you can see, so I'm calling this SingleStore Prime Radian. If you follow our foundation, you would know what I mean. So let's load this. And what it will show immediately is that in my knowledge store, I have two unstructured files or two PDFs. One's about SingleStore AI. The other one is SingleStore Client Library. And I could go in and upload more documents, which will be chunked and then added into our database. And there is also asking that data, similar to what you would see in enterprise search, but uses more accurate responses using a bunch of different techniques, which I wrote about on a Medium article, and I'll share differently. But what's important is if you look at this based on what this system found from the knowledge that we have uploaded, it has found a bunch of different entities and relationships. So this word SingleStore is an entity and it has a bunch of different relationships. And if you hover over this, it would eventually also show you the kind of relationship as it has. So we are going to utilize this along with semantic chunking in order to get our answer. So now I know what the document is about. I could ask something like, tell me about SingleStore AI features. And this is mentioned across a bunch of different things within the document. So the retrieval goes into both the vector search, the keyword search. It does re-ranking. It then goes into the relationships and the entities. These are the different search results it finds with the score, which is ranked. And then it creates the context, which it gives to a large language model, which is classic RAG, but now with knowledge augmentation, and gives the answer. So as you can see, this is a very simple example. I'm going to open source it. You can just utilize it on your own projects, and then you can take it further as well. Just to give you an idea, what does the table structure look like? It's pretty simple. I have a chunk metadata just to store the chunks metadata into it. I have a list of documents, all the PDFs that I've uploaded. Here's the entities and relationships that is found or discovered using an LLM and then added into these tables. The processing status is an async job, which I use Celery for to chunk the document and then do some extraction and then put it back into the database. So it's to keep a track of the jobs. And the document embeddings is where we store all the different chunks of the text along with the vectors associated with it. And then when we do the retrieval, that's when it utilizes all of this in a single shot and then returns the answer to you. You can, like I said, download this. It has a backend as well as a front end, and just play around with it and let us know if you have any questions.